let's just move to the Python part. So here first I'm just loading some libraries from scikit-learn. So this is the applied part of the course. So based on name of the course, this is the part that you should definitely pay attention to. So here I have a data set on stock market. So the data looks like this. It's each row of the data is a specific day, and we have these predictors, lag 1 all the way to lag 5, volume, and then direction is the response. So this is the index S&P 500. Direction is, whether this index, increase or decrease. And lag 1 is amount of increase or decrease 1 day earlier, lag to 2 days earlier, all the way to lag 5. Volume is the total volume of the stocks traded in $1 billion. And the idea here is to predict whether this index S&P 500 goes up or goes down based on patterns in the 5 previous days and volume. So we can fit a logistic regression model like this. First, we define the formula. So y and x, we define them like this. Y is direction. X, matrix X has these predictors. So this is X, or sometimes we refer to it as the design matrix. These are our predictors, and this is our response. For example, you can see that on for the first row, the index was increasing. Second day, it was increasing, and so on. So for fitting a logit model or logistic regression model, we just need .logit and then providing response. This says, column index 1 of the response, which is this one. As it is binary, we can just consider this, right? And X is the matrix, the design matrix. So we fit it, and you can see that none of the predictors are statistically significant. This is somewhat expected, because if it was so easy to kind of model and explain when an index goes up and down, we were not here. We were just, swimming in diamond and gold. So if we now use this model to make predictions and compare those predictions to the actual response values, first of all, we can see that the predictions that the model provide, all of them are close to a half. That's another indication that this task is challenging for the model. So now we're going to use a threshold of a half. So whenever it's larger than a half, we consider the prediction to be class 1. So then our classes are like these. These are the predicted classes. And now based on whether these predicted classes match with the actual classes, we define the confusion matrix. So the confusion matrix looks like this. This is true positive. This is true negative. And you can see that these are the cases where we are misclassifying. Now, if we look at some accuracy measure, we are just 0.52 accurate, or 50.